Okay, so I want to discuss this question. This question was today's Atcoder D problem, and I found this question quite interesting because you need to do some extra optimization in this question to in order to solve this question. Otherwise, you are going to get really if you are solving this question brutally. If you can see the constant, then you will get it. Why you need optimization? Because yeah, it was quite easy solution in big of n into q, big of n into q, but that was not acceptable. So you need to optimize this code, your code, or you can solve this code in n log n, n log q, or q log n, this kind of thing. Okay. So talking about the question, what has been asked in this question is that let's discuss. We have been given one array. Let's take b of size n, and we are also given another two array. Let's take b1 of size q and another vector of v2 of size q. Okay, so these are three vectors we have been given. V vector which indicate that we are given n point. Okay, so b0, b1, b2, dot 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 bn. This will basically indicate that you have been given with n point, and then b1 which indicate that you have been given q point, and b2 which indicate that you have been given q query. Basically, you can understood like in this way. Okay, so if we'll talk about what has been asked in the question is that suppose b1 of I. Okay, so let's take example and then we can understood it in more clear way. So let's take this example. Okay. See, you have been given n into q, that is 4 and 3 in this case, and then you have been given one vector v of size n, that is -3, -1, 5 and 6 of size 4, and then you have been given another vector, that is -2, 2 and 10. You can consider it as a vector v2 of size q, and in this case q is 3, and then 3, 1, 4 you can consider this vector as v2 of size 3, right? So what has been asked in this question is that you have been given this vector -3, -1, 5 and then 6, and then we have been asked that suppose if we will take this 2, 3, and then you are asked that you have to find the k smallest distance from this point -2 to all the point which has been given in vector v. Okay, and similarly if we talk about this 2, 1, then you have to print the first smallest distance of this point 2 to all the point. You have to consider the distance of 2 from all the point which has been given in vector v, and then you have to tell what is the first smallest distance that you can get, right? And similarly if we talk about 10, 4, then you have to consider the distance of 10 from every point which has been given in vector v, and then you have to tell what is the fourth smallest distance you are getting after computing all the distance, right? So this has been asked in the question. We will talk about this test case -2, 3. Then let's find the distance of -2 from every point which has been given in vector v. So what is the distance of -2, -1? That is 1, and the distance of -2, 1, that is 1, and the distance of -2, 5, that is 7, and the distance of -2, 6, that is 8. Okay, and if you sort the vector, and you have to find which is third smallest distance in this vector, or in among all the distance which you have calculated. So third smallest distance is 7, I guess. Yeah, 7 it is. So you have to print 7. Okay, and let's talk about 2, 1. 2, 1. Okay, let's erase all the things. Okay, you have to you have to take this point, and from 2 you have to calculate the distance from each and every point which has been given in vector v, and then you have to compute what is the first smallest distance among all the distance, right? So what is the distance from -3 to 2? That is 5, I guess. Yeah, 5, it will be 5. And then -1 to 2, that is 3. Okay, and then 2 to 5, that is 3, and then 2 to 6, that is 4. And you can see 3 is the first smallest distance that you can get among all the distance, right? And if we'll talk about 10,4, then let's compute that also. Let's erase all the things first. Okay, so 10,4 is the 10 is the given point, and then we have to compute the fourth smallest distance in among all the distance, right? So let's compute it all the distance from the 10th. What is the distance of -3 to 10? Distance between -3 and 10, that is 13, and distance between -1 and 10, that is 11, and distance between 5 and 10, that is 5, distance between 6 and 10, that is 4. Okay, so which is fourth smallest among all the distance? First smallest, second smallest, third smallest, and fourth smallest. So we have to compute for all the query q in this way, right? We have to calculate the v2 ith distance, smallest distance of this d1 ith in vector among all the if you calculate the distance from all the point which has been given in vector b. So I think you have understood the question. So now we can move to the solution part. Okay, so how will you do this? So for solving this question, my first approach was, okay, I will go to, okay, so let's copy this test case, -3, -1, 5, 6, -3, -1, and then it is 5, 6. Okay, so this is what I have been given as vector v. Okay. And then suppose let's take this -2, 3 as one of the test case to understand what I am telling here. What will you do? We can solve this. The first approach that we can think about this question is brute force. What will we do is that we can consider one vector, and then we'll go to every point of v, right? And then we'll compute the distance of every point of v to -2, and then we will store all the value, and then we will sort the vector, and then we will return the element which are present at third index in vector distance. Okay, so let's do the things. Suppose I have been created one vector d, and then I will compute all the distance from -2 to all the point in vector v. So that is the distance from -2 to -3 is 1, and then -2 to -1 is 1, sorry, -1 not, and then -2 to 5 is 7, and then 8. Okay, so this is what I have been I have calculated the distance vector. And then what I will do, in this case it is sorted, otherwise we will have to sort this vector d, and then we will do this thing, print d of 3. Okay, and then you will get, and I will do this thing for every v1 of I, right? It means I will have to run the second loop k times, and then also I will have to sort the vector that will take the complexity of n log n, and then ultimately we are going to get the complexity as n star q plus there will be n log n for sorting, right? So see, you are going to get TL in this case because n into q is too large in this case, because if you see the constant, then n is 1e5 and then q is 1e5, and eventually you are going to get TLE because your complexity is going 1e10. That is not acceptable, right? And then you have to think some of the optimization in this question. Okay, so I think you have got why you will get TLE, and then we will move toward the optimization. Okay, so let's take this test case only, -3, -1, 5, 6. Okay, so -3, -1, and then 5 and then 6 and then minus 2 comma 3, minus 3 minus 1 5 6 minus 2 comma 3. Okay, so this is what I have been given, right? So what I will do is that uh, okay, so can you think of the code in log n kind of things or q log n kind of things, so that because this code is not this question is not going to be solved in big of n or big of q. So yeah, and since big of n into q is not acceptable, you are going to get TL in that case. So can we think of n log q or q log n kind of things solution? Yeah, we can think of like we can think of binary search in this case. Okay, so how will you do binary search? Yeah, we can do binary search, but how? Okay, so see, I will always sort this vector v. This vector v will always be sorted, and then I will go to each and every point of this v1 of I and v2 of I, and then I will ask, suppose I will take one search space, and then I will compute the mid, right? And then I will compute one interval, and I will ask myself, if mid will be if mid is my answer, then how much interval do I get, right? So okay, so I think you are not getting what I am telling here. So let's take some example. Minus 3 minus 1 5 6, minus 3 minus 1 and then 5 6. Okay, and then that is minus 2 comma 3. Okay, minus 2 comma 3. Okay, so what I am telling is that I will take one some interval that we are doing in binary search, and then we will compute the mid, and then I will claim that this mid is my answer. But if this mid will be my answer, then if this mid will be my answer, then minus 2 plus this mid and minus 2 minus this mid, right? I will calculate all the number in this all the number of in vector v in this interval, and I will check if this interval is greater than equal to v2 of I or not. v2 of I means we have to compute the v2 of ith smallest distance in distance vector, right? So whatever we have calculated in distance vector earlier. Okay, so I will calculate one range, that is minus 2 plus mid and minus 2 minus mid, and then I will search how many numbers are in between this range, right? If this number is greater than equal to the k or v2 of I, then yeah, this mid might be my answer, but that is not sure that mid will be my answer, right? So since I will have to search for this exactly k, or we can say v2 of I, we can say v2 of I number, v2 of ith smallest distance, I have to compute for exactly this much, then we will just do these things, that whatever number are coming in this range must be greater than equal to v2 of I, then that might be answer, and then we will go for search a smaller number of interval, Okay, so we can dry run on this test case, and then we will get what I am telling, right? Okay, so minus 3 minus 1 5 6 and then minus 2 comma 3. Okay, minus 3 what was minus 3 minus 1 5 6. Okay, minus 3 minus 1 and then 5 and then 6. Okay, and then minus 2 comma 3, okay. So let's take in this case I am taking the interval as small. Let's take 0 comma 20 as my interval search space initially, and then I will compute the mid. Okay, so what is the mid? 0 plus 20 by 2, that is 10. Okay, so 10 is my mid, and I am claiming that this will be my answer. Okay, so I will compute the I will go and then compute the things like minus 2 plus 10 and then minus 2 minus 10, minus 2 plus 10 and then minus 2 minus 10. Okay, so in this case I am getting 8, and in this case I am getting 12. So I will search for every number which are in this range between this minus 12 and 8 in this vector V. Okay, so how many numbers are in between this minus 12 and 8 in vector V? I think all number are in between this range. Okay, so how many numbers are there? That is 4, right? So is this 4 greater than 3? Yeah, then 10 might be my answer. But is this correct? No, in this case I was getting 7 as an answer. So I will go and then since I will have to find the third smallest distance, but I am also getting the fourth smallest distance in this case. Do I need this 4? No, I don't need this 4. I will have to reduce the search space in order to get the this much number in my as a mid. Okay, so I will reduce the search space from 0 to 20 to 0 to 10. Okay, and I will take the mid, that is 5. Okay, and then I will compute all the things, that is similarly minus 2 plus 5, that is 3, and minus 2 minus 5, that is 7, minus 7. Okay, so how many numbers are in this range? Minus 7 to 3. Yeah, this is in range, but these two are not in range. Okay, so here I am getting 2 number, right, in this range, and which is greater than equal to 3? No. So I am sure at this point that this 5 will not be my answer. And what will be my answer? Anything which is greater than 5, because I am getting the lesser interval, lesser number of distance in lesser number of point in vector V in this interval, in this range, right? So what I will do, I will shrink this search space, but I will shift this search space from 0 to 5. Okay, so now my search space is between 5 to 10, and then mid is 7. 10 plus 5 by 2, that is 7. Okay, so can 7 be my answer? I am claiming that 7 will be my answer. Then I will ask myself, if 7 will be my answer, then I will do the same things like minus 2 plus 7, that is 5, and then minus 2 minus 7, that is minus 9. Okay, so how many numbers are in between this range? Minus 9 and 5. Okay, so this is in this range, this is in this range, and this is in this range, but this is not. Okay, so how many numbers are there? That is 3, and which is exactly equal to these 3, right? And in this case I got the answer. So 7 will be my answer. So in this way I will do binary search for each and every I in V1 of I and V2 of I, right? And I will go to Q. So in this case, what will be my time complexity? My time complexity is Q. I will be running the outer loop for every integer in V2 and V1, and that will be Q. And then I am doing binary search, that will be equal to binary search on vector V, and which is of length n, so it will be equal to Q log n, and that is acceptable code. Okay. So I think I have explained the logic of this question. Now we should move to coding part, right? So let's see that. Okay, so this is what I have been written. This is the code of this question B. Okay, so first of all, what I will do is that I will take the input as n and q, and then I will create one vector of size n, and then I will take the input. Here I have taken the input of vector v, which was the initial vector, and then I will sort the vector v, right? And then after that I will take the vector v1 and vector v2 of size q, and then I will take all the input. Okay, so I will and then I will go to each and every point in vector v1, like I will run the outer loop from 0 to q, and then I will compute this. I will take this low and high somewhat bigger range, like from 0 to 2 into 10 to the power 8, right? Because if you see the constant in this question, then we have to do the things, because yeah, this ai and bj is from minus 8 to minus 10 to the power 8 to minus 10 to, plus 10 to the power 8. So yeah, it might happen that at some case we can get the number equal to 2 into 1e8, right? So I have taken, for that I have taken this much longer number. Okay, so every time I will go and then find the mid, and then I will claim that this mid is my answer, right? So what I will do, I will compute this LNR, which we are doing, we are finding this minus 2 plus 10, minus 2 minus 10 every time. So that thing only I have done here. I have computed LNR, and then I will compute that how many numbers are in how many numbers of distance are in this range from L to R, and then for that we can do lower bound and upper bound on L and R, right? And then we'll check if this CNT, if this CNT is that is the difference between IND minus 2 and IND 1, and if we'll check if this CNT is greater than B2 of I or not. If it is, then that might be my answer, but we'll have to search for some smaller answer, right? So we'll shrink my search space to high is equal to mid minus 1, and then if this is not the case, then we'll do low is equal to mid plus 1, and we'll do this thing again and again and again until unless we'll get the right answer, right? And whenever I will get the answer, then I will just print the answer, and then yeah, this question is done. So so look, let's submit this code, and then yeah, I will. Okay, you can see this is accepted here. So I think I have explained everything in this question. Okay, so thank you for now.